All right, today we're gonna make a cable. Cables are super important. You gotta get electrical signals where they need to be. So the first thing you need to know about making your own cable is don't do it. If you can buy a cable, you should buy a cable. They're much better. They got better strain relief. They don't break. Normal cables break. Like I've had cables just sitting there doing nothing, just open, like in the middle, not at the ends. Cables are not great. So buy it if you can. But if you have to make it, this is the way to do it. And so we're going to show you a simple way that we're going to wire up our thermometers in this adiabatic demagnetization refrigerator you see here to the electronics that are in the rack right next to it. And so we'll go through the process of making this cable. All right, so here's the job that we need to do for this cable. So first we have a D-sub 25 pin connector. That's what's on the fridge. So this is the right connector for that. Then on the other side, we have this 5-pin connector that is what Lakeshore uses for their thermometers. I don't know why they use this one. It's historical. So what we're going to have to do is use this piece of wire and connect the two together. We have the pinouts, which we've already figured out. Josh went through and figured this out. So we know where everything's going to go. So now we just have to make it all work. First thing we got to do is strip off the insulation from the wire. You don't need much. We'll do the D-sub end first. So we can put this in our little. All right. So we're going to strip off just a little bit of this insulation. This is probably not the best way to do it. You want to not get into the actual cable itself. But if you kind of nick it with the scissors, you can then usually kind of get it to go without causing too much damage. All right, so we got it off. Now this cable is a shielded twisted pair with 4 conductors. So you got this is the ground lead. That's connected to this tinfoil ground shield that you see on this side. All right, so we can just pull that back for now. This shields the wire from interference and is a nice thing to have. But you have to actually be careful. Depending on the system, you probably don't want to connect this ground shield to both sides because you'll get ground loops. So what I usually like to do, and what they usually tell you to do, is you'll actually ground it to the instrument and then not ground it at the doer side. That'll give you better noise rejection and avoid ground loops. But for now, we've just got these, and we can just rip off the foil because we have the wire. All right. So we have in here 4 wires. Okay, annoyingly 2 are black, so we're going to need the multimeter. All right, so what we're going to do is strip off a little bit of the insulation, and then we got to solder these into the right holes. All right, so we've got the wires. We've got to strip these wires and then solder them into the right place. Okay. All right, so we will make, we're going to do the 4 Kelvin one first. We'll make I plus white. So we'll now need to solder that into pin 4 on here. Pin 9, yeah. All right, so the way to do this soldering is you find the right pin. I need to use these glasses because I can't see a damn thing without them. It's way too small. You can usually insert the wire in there so it's you know, nice and it goes into the solder cup. And then you got to solder it. And now the trick with soldering is you have to get the wire and the solder cup both hot and then feed the solder in. If you don't, you can get something called a cold solder joint, which looks like a real solder joint, but is gonna break. So that's what we're gonna attempt over here. And you may or may not need some solder flux to pull this off. It's not my prettiest soldering job, but it'll probably work. So another question people might ask is, should I put heat shrink on there? I think the answer is no. You can put heat shrink on, but the problem is it makes it hard to see if there's a problem with the joint. So unless you have a really good reason, I would recommend not using heat shrink. And actually, I think I'm gonna realign this one a little bit to try to get it to come out a little straighter from the cup. Okay, that's better. Now we have it coming out vertically. So tweezers are helpful here, and also having, we have some things that will hold the wires for you, which can also be helpful. Now we got to figure out which is this guy's buddy. So these are in twisted pairs, so we want to figure out who this is twisted with. I think the answer is this one, but it's a little hard to tell. Annoying that this cable doesn't use a different color wire, but we'll just assume it's this guy. All right, and so we will hook this up to pin 10, which is right next to it. There we go. All right, so those two are in. Now we got to do pin, so I minus is going to be red. Okay, and we want that in pin 21. That one was picture perfect. All right, and then the next one, the black wire that's associated with it, is going to go to pin 22. All right, so this side of the connector is done. Now we can do the other side. All right, so these are the connectors that the 5-pin connectors are. They're kind of a strange little circular connector. You can unscrew this, and then that pops out. And then you need to feed on the strain relief boot onto the wire. Let's see if sometimes this will work. A little isopropyl will actually lubricate it a little bit without damaging too much. Actually worked. All right, so then we got it on. Now we have to strip the end. Pretty sure this side has to go on too, actually. Yeah, because it doesn't go through. Yeah. So we got all the parts on the cable. I'm slicing it. Now I'm giving it a little bit of elbow grease. All right. So we're going to take off the shielding. Okay. So white is going to is I plus, which we have decided is going to pin 5. All right, here we go. Good times. All right. All right, that's in. All right, now we got to make sure we have the right black cable here. So we'll set up the multimeter. We'll set this one to the red guy's buddy using this clip. Okay. And now we can check and make sure that we're on the right one. My guess is it would be this guy. And yep, 1.3 ohms, good. So that is our so that's going to go into pin 5, right? I'm going to have to get a pair of tweezers for this, aren't I? Oh, actually worked. All right. It's in. Okay. I put a little too much solder on there, so I'm going to show you a trick to get rid of the solder. This is a solder sucker. So I'm going to go in there, I'm going to heat it up, and then I use that and it sucks it off. So we are good to go. All right, now we have to do the other two. Okay, so red we've got going to I minus, which is pin 1. Good. All right. All right. That was the last one. Now there's a question here, which is what to do with the shield wire. Now there's two, we can either attach it to the empty pin there or to the shield, which, or to this thing that sticks out. Now, I don't know exactly how the Lakeshore 340 is connected, so I'm gonna go and measure it and see where the Lakeshore 340 has its ground connection. So the Lakeshore looks like it has its ground on this big piece of, on this big round shield right here. So what I'm going to do is just solder the ground wire to the shield here, just so that it's tied together on this end. And the other end there won't be any ground connection. All right, so now let's test it, see how it goes. So right here we have the one side of the connector plugged in. It is working as expected here. We have the wire going here. We haven't closed it up because we wanted to test it. So here we've got this plugged in on the back. And now if we go over to the front, we can see on this very dim screen, you might be able to make it out, that we're at 293 Kelvin. So that is working. We are currently reading out the 4K sensor. So that's great. All right, so it's working. Now we just have to do that for the other thermometer, and then we'll be able to monitor the temperatures as we cool this fridge down for the first time.